conversation. All right, so we're only going to concentrate on two radical graphs, the square root graph and the cube root. So the parent function for the square root y equals, or f of x equals square root of x. And so we want to remember the shape of the square root function. So it has a curve to it. It has an endpoint, and then there's a curve to the right. All right, so that's the shape that you want to memorize. So it has a starting point, which is our endpoint, and then has one arrow. All right, then the cube root is the S shape, but it's going to run horizontally, kind of like the cubic, okay, which runs vertically. So the cube root runs horizontally. It has two arrows. If you kind of cover up the bottom part of the cube root function, you get the square root function. Right there. All right, so on the transformation stuff, everything on the inside of the radical, underneath the radical, affects the x values. It does the opposite of what it shows. You got to remember opposite of everything inside. And then everything on the outside affects the y values. It does exactly what it shows. All right, so let's go ahead and graph this first one. So the parent function, this is just the square root function. So y equals the square root x is our parent function. And so we can make an xy table. And so we want to pick some x values that we can plug in underneath the square root, okay, and take the square root of that number. So if you remember when we did this back in Unit 1, what were three x values that worked really nicely? 1 and 4, there's one more. 9 works, but there's one more that's smaller. The actual, the first one. No, you want to do square root of 2 because that's like the decimal. The first perfect square. We got 1 and 4. There's one smaller than 1. 0. Yeah, 0. So we always want to use 0, 1, and 4. Those are the first three perfect squares. Now, if you want to use 9, you can. If you want to use 16, that's fine also. Okay, but 0, 1, and 4 are always the first three that we want to use. So now when we take 0, plug it in for the square root, okay, plug it in for x, and take the square root of it, we're going to get 0. All right, and then we take 1 and plug it in for x. The square root of 1 is 1. And plug 4 in. Square root of 4 is 2. And then if you want to use 9, square root of 9 is 3. All right, so memorize 0, 0, 1, 1, 4, 2. That's our parent function. All right, so then we can apply the transformation to these values. So remember, everything on the inside affects the x values, and it does the opposite of what it shows. All right, so it says x minus 1, so we do the opposite. We're going to add 1 to all the x's. All right, now everything on the outside affects the y, and it does exactly what it shows. So it says to add 2, so we're going to add 2 to all the y values. All right, so we take each x value, add 1, take each y value, add 2. So 1 plus 1 is 2, 4 plus 1 is 5. If you wanted to use the 9, 3 one, you could. 9 plus 1, that would get you 10. All right, and then plugging the y values in and adding 2. 3 plus 2 is 5. All right, so then we have our new x and y values that we can plot. So 1, comma 2, 2, comma 3, 5, 4, and then if you wanted to use that 10, 5, you can also. All right, so we always want to remember what the shape is supposed to look like because all we have are some dots on there right now. So we have to remember that the square root function has an endpoint, a starting point. So your starting point is always going to be your first ordered pair that you graph, okay, in your table. right? Because it's coming from 0, 0, right? So now it's 1, 2 is our starting point, right? So that's our starting point, and then we can just connect them and get our arrow going to the right. All right, so it has a slight bend, a curve to it. It's not going to be like a straight ray. All right, then we can apply or state the transformations that occurred from the parent function. All right, so it looks like we went right 1, up 2. Now we can plot these, the parent functions, just so you can see it. So if I plot this, I'll just use a different color, 0, 0. Here's 1, 1, 4, 2, 9, 3. So you can see how the blue graph transformed from the parent graph, which was the red one. The red one is the starting one, and then you can see the whole graph shifted to the right one, up 2. All right, now we also want to state the domain and the range. All right, so what would the domain of this graph be? It's off the blue one. I just put in the parent one just so you can see how the transformation works. All right, good. So we're going to work left to right. We're asking ourselves what vertical lines intersect the graph. And so if we start at negative infinity and draw a line, we can see that this line right here will never intersect this graph. All right? So we slide it over until we hit it. So it's going to hit right here at positive 1. That's where it starts. All right? And then it will continue to hit all the way over to positive infinity because the arrow shows that it keeps going forever. So it's going to be from 1 to infinity. Now we're going to use a bracket on the 1 because it does hit. So 1 to positive infinity. All right, now what would the range be? 2 to infinity, right. So with range, we look at what horizontal lines are going to intersect the graph, and we move from bottom to top. So we're down here at negative infinity, and this horizontal line down here will never intersect this graph up here. So we slide it up, so it hits. First hits at positive 2, and then it will continue to hit forever. So we can say from 2 to infinity. All right, so let's do number 2. So again, this is just the square root function. So we start off with the exact same 3 values. Again, if you want to put that 4th one in there, you can. But 0, 0, 1, 1, and 4, 2. Always start with those. All right, so then we'll apply the transformation. So x plus 3 means that we're going to go left 3. Okay, so we're subtracting 3. That moves it to the left. On the y's, we have to work on the outside and go left to right. So anything that's being multiplied in front of the radical has to be done first, and then anything added or subtracted gets done last. So we have the negative in front. So we're going to multiply each y value by negative 1. Then we can subtract 1. Okay, so multiply by negative 1, then subtract. All right, so plugging 0 in for x, minus 3 is negative 3. Plugging 1 in, that's going to get us negative 2. Plugging 4 in, 4 minus 3 is positive 1. All right, and then our y values, plugging 0 in for y, multiplying by the negative 1 is still 0. Minus 1 is negative 1. Plugging positive 1 in for y, multiplying it by the negative turns to negative 1, then subtract 1, be negative 2. Plugging 2 in, so that becomes negative 2 minus 1 is negative 3. And we'll plot those 3 points. Right, so again, we want to find the endpoint, and so that has to be the first ordered pair, negative 3, negative 1 is the endpoint. All right, and then we'll connect them with our arrow going to the right. All right, now we can describe the transformations. Left 3. X-axis reflection, that's the negative in front. Down 1. So if the negative's on the outside being multiplied, it does an x-axis reflection. If the negative's on the inside of the radical being multiplied to x, that's a y-axis reflection. All right, then our domain, as we move left to right, negative 3 is going to hit first. And then the range, as we move bottom to top, it will hit at negative infinity first, because it's going down. And then it'll stop at negative 1. All right, so the cube root. So our table, our xy table, is based off the parent function, the cube root of x. Now with cube roots, we're not restricted by any x values. Square roots, you can't do the square root of a negative. That's why we didn't put any negative x values in the xy table, okay, on the x side. You had to start with positive. You had to start with 0, and then you can only use positive perfect squares. All right, so that's why we use positive 1, positive 4, positive 9, because you can take the square root of those numbers. You can't do the square root of a negative. But with cube roots, you can take the cube root of a negative number. The calculator will calculate it. All right, so you're not restricted by any number with cube roots. You can do negatives, you can do positives. So with cube roots, what three x values can we pick that would work nice? Positive 1 would work. 0. 8 would work. You can use negative 1 also. All right, you could use negative 8. So negatives are okay with cube roots. All right, it's just not with square roots. Square roots and fractions are the two functions where you can't use any x value. You can use only certain ones. There's certain ones that you can't use. Like on the square root, you can't use negatives. With fractions, you can't use 0 because you can't divide by 0. Okay? But with any of the other functions that we've talked about, you could use any x values you want. So we want to use negative 1, 0, and 1. Okay, those are the three smallest ones. Now, when we take the cube root of them, again, you have calculators, scientific calculators, you can throw these in to verify it. The cube root of negative 1 is negative 1. The cube root of 0 is 0, and the cube root of 1 is still 1. So the three values that we want to memorize for cube roots, negative 1, 0, 0, 1, 1. Now the transformations work the same. Okay, it's just the parent function values are different, but the transformations all work the same. All right, so now when we do our transformations off of these values, we're going to add 2 to all the x's. We're going to multiply all the y's by 4, then we're going to add 1. Okay. Outside, you got to go left to right. So you got to multiply first, then you can add or subtract. Remember, inside does the opposite. All right, so -1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3. Okay, our y values, -1 times 4 is -4, plus 1 is -3. Plugging 0 in times 4 is 0, 0 plus 1 is 1. And plugging +1 in times 4 is 4, plus 1 is 5. All right, so now we just plot those points. So 1, -3, 2, 1, 3, 5. All right, so again, this is a cube root, so we got to remember what the shape looks like. So it's going to look something like this. Because of that 4 in front, that's stretching it out vertically. Okay, that's why it looks. That's why the gap or the space between these 3 points right here are spread out. Right, so because of that 4. All right, so then describing the transformations, we can go right to vertical stretch by 4 and up 1. All right, so again, just so you can see the parent function, if I just plot those 3 values, -1, -1, 0, 0, 1, 1, that's basically what the parent function looks like. All right, so what would the domain of this cube root function be? Good, -infinity to +infinity. So every vertical line will intersect this graph at some point. And then the range? Good, it's going to be the same, -infinity to +infinity. Every horizontal line will intersect this graph at some point. So one thing that's nice about cube root functions, the domain and range is always going to be the same answer, -infinity to +infinity. All right, so let's do this last one. So again, we have a cube root. So -1, 0, 1. Taking the cube root, we get -1, 0, and 1. Subtract 3 from all the x's. And then all the y's are going to get multiplied by -1/2. All right, so -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. -1 times -1/2 is +1/2. 0 times -1/2 is 0. 1 times -1/2 is -1/2. We'll plot those points. So -4, positive a half. -3, 0. -2, negative a half. So now I just got to get the shape in there. All right, describing the transformations, look like went left 3. X-axis reflection. And vertical shrink by a half. And the domain and range are the same. Answer every single time for cube roots.